Good morning, everyone. This is the first lecture we are going to have on the electric motor evolution in and the subject which we are dealing is electric vehicle traction motor. So this is kind of a training session in which we'll see that how many motors are being evolved in the EVs since the start, and what are the phases in which the EV have been evolved or they have get down by the IC engines, and to know that what are the motors being used in today's modern EV types. And later on, we'll take those one, we'll see their characteristic, we'll see the requirement as per the EV load, and then we'll also see their suitability in the vehicles and how we can enhance their efficiency, how we can enhance their performance specifically for the EV load uh, along with that. So this is going to be the overall objective of this course. So we start with the EV evaluation uh, since the 1828 to 1830. So we can divide the EV evaluation in the three category. It was the first when we have started EV. Then EV has gained some popularity, not that equivalent to the IC engines, but it has gained some popularity somewhere uh, it, near to 1890 to 1910. And then due to the evaluation of IC engines and very much research being done in the over the IC engines, and the engines get refined and some other limitations along with the EV. So EV has come down, and ICE engines have picked up as the first choice by the consumers. So we are going to divide the three regions, and then also we are going to see uh, in these three regions what are the motors, how the electric motors being evolved since 1830 to currently in 2024. So as it is written over here that in 1828, the first commercial electric vehicle powered by the simple electric motors is being deployed, and thereafter it gained some interest in the research community. And in 1830, Robert Anderson develops the first crude electric vehicle, and then it was on the whole, due to some reasons, it does not pick up that much pace. The main limitation was that it has only a top speed somewhere in reaching to 25 to 30 kilometer per hour. But later on, as the advancement happens in the electric motors and in transportation systems, so in 1880 or 1890, near to that, EV has raised popularity. So as we have already uh, discussed that somewhere around in 1890 to 1910, EV has gained popularity for being quiet and easy to operate. And this characteristic is given by the motors being used in the EV, whereas IC engine has noisy, they are uh, having uh, tough to maintain over the DC motor compared to the DC motor. So these are the some advantages which is being offered by the DC motors that time being used in the EVs. So 1819 and 1910 was the era when the DC motor was being deployed in the EVs, and that was also written as the golden age of EV. However, just after 1910, uh, due to the gasoline vehicles dominated due to better range and cheaper fuel, because fuel price came down, and IC engines were giving more range compared to the electric vehicles, where the electric vehicles was only uh, being run for up to the certain distance, maximum 20-30 kilometer, with the top-notch speed is somewhere reaching around to 30 to 40 kilometer per hour at that time, whereas the IC engines were giving a better range, So it was giving the better comfort to the consumers. So therefore, the 1920 to 1916 was dominated by IC engine vehicles, and we have also witnessed all that dominance by the IC engines. Today itself, the market captured by the IC engine is more than 95% compared to the electric vehicles, which is uh, less than 5%. However, the scenario is getting changed in due to the uh, SDG goals and environment policies, global warming, and many other factors. We again have opted for the electric vehicles, and along with it, our motors also get evolved during this half of century. So the resurgence of EV started somewhere around in 1965 to 1970, but that was not due to the environmental policies or the concern towards, say, uh, global emission, CO2 emission. However, it was due to the oil crisis which being happened in 1970. So the oil crisis mandate that we should also look for the alternate solution for the transportation purpose. So therefore, EV again researched as the alternate solution, and the uh, companies started again working towards the betterment of the electric vehicle. So in the era of 1992 to 2000, hybrid vehicle came into the picture. Not they were not the purely electric vehicles. We know that hybrid vehicles, which some uh, fuel being consumed from in the form of the petroleum products, and the other source of the fuel is, or the source of power is, the battery. So it was the hybrid combination of fuel, petroleum fuel, plus the battery storage. And we also know that the battery evolution of the battery over the years is also main reason that today's we are talking about the EV as a first option for the transportation. Because in the early 90s, the lithium ion batteries were not being used on the commercial scale. They were still on in the research domain. The lead acid batteries were being used that time for a battery storage purpose. But as we have evolved for the storage, we also have found the solution for the betterment of the EV range and the top speed of the electric vehicle. So along with the motors, I would say the advancement in the battery storage plus advancement in the power electronics, which comprise of conversion of the power through inverter, converter, rectifier uh, by the semiconductor devices. So semiconductor devices or semiconductor chips, which is being developed over the years, as now uh, have gained sufficient amount of research, and they are efficient enough to give us uh, pure, near to pure sinusoidal waveform for our AC motors. And if we want the DC supply for the other purpose, then also ripple free DC supply we can get it from by the use of the either the inverter or the rectifier made from the semiconductor devices. So all these factors come into the picture, and then we are currently talking about the EV as a first choice for the transportation system. So coming back to the resurgence of the EV, so Toyota Prius was the hybrid vehicle introduced by the Toyota somewhere in the 2000, and then in 2008 Tesla Roadster revolutionizes the EV market. So Tesla played a huge role towards the popularity of the EV, we are seeing in the today's time. Key development, as I've said, the improved battery technology. Nowadays, we are using the lithium-ion batteries. Advanced power electronics like inverter, converters, rectifiers, choppers, all being made from the semiconductor devices. Again, gained sufficient amount of research, and they are able to give us what we are looking for. And during that time, during the 2005 to 2010 to 15, the motors which is being used in the electric vehicles uh, were AC induction motors, and also in some of the model DC motors also being used. So here we are specifically talking about the cars, whereas if we talk about the two-wheelers still uses mostly two-wheelers still uses the uh, BLDC motors. They don't uh, use, or they don't deploy the AC motors. Most of the two-wheelers variant, they don't deploy the AC motors. Instead, they use the BLDC motors. So types of the motor used in the modern EVs, as I've said, in the earlier EV models, which up to the 1910, in the early age of the EV, the DC motors were popular, and they were being used in EV applications. Whereas the mid age of EV, I would say from 2005 to somewhere around 2015-16, AC induction motors were deployed in EVs. The advantage of the AC induction motor is that the efficiency is on the higher side, reaching up to the 93-94% in EV application. They have low maintenance cost compared to the DC motor, because DC motor has brushes and the other uh, things which ask for the regular maintenance, where these things are missing in the AC induction motors. And they are very robust also, so they can work in the tough environment like having dust and moisture. So AC induction motor withstand in very strongly in these kind of environments. So AC induction motor becomes the first choice for the EV applications. However, uh, as I've told you, that as the EV gain popularity, the research in the various dimensions has also gained the popularity. And the three main directions are, one is the storage, the other one is the motors, and the third vertical, I would say, mm, the power electronics. So motors were also being checked constantly for better EV applications. And then the other motor, which nowadays being used in most of the Indian electric vehicle models, that is the permanent magnet synchronous motor, also shortly known as the PMSM motor. So nowadays, if we talk about the Tata Nexon, it uses the PMSM motor. Tata Tigor, the new model, is also uses the PMSM motor, and the other variant also, which is available in the Indian market, uh, being deployed with the PMSM motor. However, the Tesla uh, has taken a leap, and we always know that Tesla is always a front runner in case of the EV. So the most popular EV model worldwide, globally, I would say, which is being sold, it is from Tesla, and that is Tesla Model 3. So Tesla Model 3 is using some kind of a combination of two motors. One is the, I would say, PMSM motor, and the other one is the from the reluctance motor, switch reluctance motor. So they have combined the property of these two motors, and they have made, uh, they have done some modification, and they have come up with the new motor, which they have given the name uh, integral permanent integral permanent magnet synchronous motor, shortly written as IPM sync RM. So we'll talk all these motors, starting from the DC motor. We'll also cover the uh, BLDC motor, which is a part of a DC motor itself, but used in the two-wheelers, and also the induction motor, which is uh, what was used in the previous EV models. So we will also talk about the induction motor and why it is being replaced with the PMS motor. There should be some reason that induction motor is being replaced by the PMS motor. So that also we are going to cover one by one. And the current motor, which is the PMS motor, how it is being superior to the induction motor, what are the control strategy, and what are the things which we need to keep in the mind, and why the Tesla instead of PMSM motor is now using the combination of the PMSM and the reluctance motor, that is the IPM sync RM. Lastly, from this session, again, the ongoing innovations in terms of the battery. We know that the lithium-ion battery is now being used in electric vehicle applications, but however, solid-state battery is also being explored for the electric vehicle applications, as well as uh, to finding the uh, how we can enhance the motor efficiency, and how we can achieve more better performance from an EV. That is also being explored every day. If we can improve the efficiency of a motor just by 1% in EV application, that can give us a range, extended range of 20 to 30 kilometer more. For an example, if let's say current EV, uh, let's say the Indian model itself, claims the range that it can run somewhere around 400 kilometer in one charge. So if we can increase the efficiency by just by 1% of the motor being used in that model, so instead of 400 kilometer, the range can be extended up to the 420 kilometer. So that is the thing which is being explored nowadays. And in coming half of decade to the 1 decade, we are very sure that the wider adoption of the EV will happen globally. And also, as the EV evolved, as the other parts of the EV evolves, like motor, power electronics, the storage, the automation part will get evolved. We know that the Tesla has come up with the uh, autonomous vehicle. However, in India, we are not reached to that uh, mark, but still, we are hoping that as will come over the first thing first, uh, I would say the problems, like giving a better range, giving the uh, faster charging of the EVs. So if we'll reduce all these hurdles, and if we'll have a better charging infrastructure in the country, then definitely we'll also look for the uh, autonomous vehicle itself. So guys, this was the kind of the introductory session which uh, I have thought that we should have it, because this will give us the history of the EV, as well as the motors being used in the EV and are deployed in the EVs in the today's model, and what are the future prospect in the motors which we can look for. So that's why this is a kind of a introductory session. Uh, Thank you very much.